Hey guys, in this video I want to I want to solve a scheduling problem. First, by method of AON, activity on node, we can use from the rectangular, which includes some cells, earliest start, duration, earliest finish, which used for toward path, and for backward we use from latest finish and latest start. This cell is related to total float. Total float have three methods to compute. First, we can use from latest finish and earliest finish. It should be, for example, subtracting the earliest finish from latest finish, or latest start, the difference of latest start and earliest start, or if we subtracting the duration and earliest start from latest finish equals to total float. This one, and this one. Okay, it shows the total float. But for earliest finish, if we add earliest start, duration to earliest start equals to is equal to earliest finish, and for latest finish, if we subtracting the latest finish, the duration from latest finish, we have latest start. Now I want to depict the AON diagram. The activity basic design and market study haven't any predecessors, so they can be linked to node of start, and it's assumed to the date 0 or not different. Maybe it can start by 1. The duration of basic design is 6 months, so the earliest finish is 0 plus 6 equal to 6. This is basic design. The basic design is predecessors for engineering. Engineering takes 3 months. After engineering, we can start prototyping. The duration is 1 month. After this is market study. After the market study is predecessor for production line installation. The duration is 3 months. The market study, the duration of market study is 3 months also. For starting the activity, production startup, both activity prototyping and product PI should be finished. Okay, and the duration is 2 months. And market studies predecessor for advertising preparation. The duration is 2 months, And after finishing the advertising preparation, we can start advertising campaign. The duration is 1, and you can link them to node page. For this activity, it should start on 6, and for its earliest finish, we can add 3 months to 6, so it's 9, and 9, put 9 here. 1 month plus 9 is 10. And for this market study, it's start as in 0 plus 3 0 3, and day 3, put day 3 here. 3 plus 3 is 6. In this covering, we should use the maximum of 10 and 6 to start activity of production startup. The maximum is 10, so we put 10 here. 10 plus 2 is 12. For this activity also, it starts at 3, finish at 5. 5 plus 1 is 6, and we should use maximum also here, maximum of 12 and 6. The maximum is 12, so the duration is 12. This is used for toward. Okay, for backward, we put 12 here. The latest finish of the project is 12, so we put 12 in here and here. 12 minus 2 is 10, so the latest start, as we use this formula, the latest start is 10, and we should put 10 for latest finish of this activity and this activity, because it's successors of them. And for activity of advertising campaign, we subtracting 1 month from 12 to calculate the latest start, so it's 11, and we use 11 for latest finish of activity of previous activity of earliest advertising campaign. 11 minus 2 is 9, and here we put 10. From this activity we put 10. 10 minus 3 is 7. Here we should use minimum of 9 and 7 to select the latest start of this activity. It's 7. The minimum of 7 and 9 is 7. 7 minus 3 is 4. For this activity, it's 10 minus 1 is 9. 9 minus 3 is 6. 6 minus 6 is 0. So it should be shown by minimum for minimum of 3 and 0 and 4, that is 0 0, and this is for latest start. And we assume for the for this program is 0, start at 0. Now we know that total flow, if total float of the durations are 0, so it shows the critical path method. Or also if the duration, if we select the maximum line, and if this select the maximum duration among different paths, also it shows the CPM. So if we calculate the total float of each activity, and we know that we see that the total float are 0, we can use that as a CPM. Or also if we write the different paths, for example in this problem we can select BS, engineering, production, BS, or that is 12, the duration is 12. Or MS, PI, PS, that's also 12. Or MS, AP, AC, that is 6. The duration is 6 plus 3 plus 1 plus 2, 12. 3 plus 3 plus 2, 8. 3 plus 2 plus 1, 6. So we can use the 12 as the maximum duration of this path. So the CPM is this one. The total float of this activity of this path, total float of this path (12 minus 12), 0. But total float of this path is 4, and total float of this path is 6. Now I want to compute the total float for each activity. For this activity, the total float should be calculated by this formula. For example, if you subtracting 12 from latest finish, it's equals to 0. 10 minus 10. This path, all of the activities have the 0 total float, so it shows our critical path method. For this path, the total float is 4, because you can use the formula of this, for example, 10 minus 3 minus 3, not different, they are the same. And for this activity also 4, for this activity 6, and for this activity 6. Now for calculating the float sensitive, because the problem has risk score, so we should use the average of activities, total float average, and risk score. Distribution for this float distribution, we should calculate the FSD for these paths. For example, for MS, activity of M, for the path of MSPI and PS, that the total float is 4 and the duration, total float is 4, the duration is 8, and risk score of MS is 8 from 10, and risk score of PI is 4. Eight and 4. Because the activity PS, the total float is 0, so it's not no need to calculate for this. The total, we should divide the actual duration of activity MS, that's 3, to its path duration, it's 8, and we should make an average of this fraction with the risk score, that is 8 to 10, make average. Multiply by PS duration. Multiply by the total float. 4. In fact, the formula of this is the actual duration of market study to path duration multiplied by total float. This is the formula for float sensitive distribution. It is 2.35. For activity Pi, the duration of Pi is 3 to 8 plus the risk score is 4 to 10 divided to 2 multiplied by total float is 4, and for the path of, this is the formula of this method. For the path of this one, MSAP and AC, that's the total float is 6 and the duration, and the total float is 6 and the duration is 6, is the same as previous path. So the duration of activity MS, is 3 divided to 6 as a path duration plus the risk score. The risk score is 8 to 10 divided to 2 because it's average of these numbers, multiplied by 6 because the total float is 6. This is for MS activity, but for the AP, the total float is 6, the duration is 2, the total path duration is 6 plus the risk score is 2 to 10 divided to 2 and multiplied by 6, the total float. And for the activity AC, the duration is 1. The duration of path is 6 plus the risk score is 2. This is 3.9, this is 1.6, and this is 1.1. It should to mention that if the problem doesn't have any risk score, we should use the float distribution without any risk score, and it doesn't need to make average between risk score and the duration. So we should compute the for example, for activity MS, the duration is 3 and the total duration of the path is 8 multiplied by the total float and without any risk score. But if we have risk, we should make an average between the duration and risk score.